artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello and welcome to episode 170. My guest today is Michael Sharpe, CEO of Magick ML, an AI development environment that gives people a way of creating agents based upon generative AI. Before that, he was at Latitude, where he worked on the AI dungeon game. Gaming nerds will understand what that was. If it has you thinking strange thoughts about that title, it is a text-based role-playing game like the old Adventure or Zork games, only it's powered by a large language model. You can find it at aidungeon.io, and we'll talk about it in the interview. Michael thinks big thoughts. You'll hear references to the paperclip maximizer, superintelligences, and one term I'll explain in advance for the non-developers among you. Turing complete, as an adjective, means that a system is capable of computing anything that any other Turing-complete system can. It's a way of saying that a computer language or environment is fully featured and not like, say, HTML, which is a declarative markup language that you can't compute functions in. You need something extra like CSS or JavaScript. So let's get right into the interview. Michael Sharpe, welcome to AI and You.
Hey, thanks, Peter. It's a pleasure to be here.
So you have created last year, and I was going to say back in the day, but then I realized it was last year, but these days that is back in the day of this sort of thing. Something that rocked my world, and that was the AI Dungeon, which for any of our listeners who haven't seen that, was the traditional, in a way, text-based kind of game, online version, of course, that you would visit through a web browser where you would get to play with a virtual world. You could pick the type of world, fantasy or film noir crime or something like that, and other choices. And then it would say, you are in the middle of a field and you're surrounded by elves or whatever, and it would make this stuff up as it went along. So I had years ago played games like Dungeon and Adventure, and even nerdily went into the source code or decompiled it at times to see how it worked and mapped it out. And there's a lot of sophisticated programming in creating that world. You got an AI to make it up by itself. That just floored me that something was that good at creating a story online. So tell us what that experience was like of being able to make that happen, because there wasn't anything like that before. And that really changed things.
No, there wasn't. I mean, it really did. It kind of created a zeitgeist. And the story behind it's really interesting, because I was hire number 6 or 7 there, right after they got their big boom. And I'm a hobbyist text adventure writer myself in the informed programming language that I utilize in combination with what are known as alternate reality games. And I was in the middle of one of these, and AI Dungeon dropped, and I was like, oh my God, I need AI in my text adventure and in my game. And I wound up reaching out, and through fortuitous circumstances, they wound up hiring me. And I had just been watching this great documentary called Get Lamp, phenomenal documentary about the rise and fall of Infocom. Right, and Infocom, very similar story. Right? So, Infocom, MIT developer, builds what became Colossal Cave Adventure, and people flocked from all over the internet, or ARPANET at the time, to play this game on this machine in MIT. You fast forward to, 2019, 2020, Nick Walton makes this, trains GPT-2 and makes a model on text adventures, and they rack up like $30,000 in ingress and egress bills to the university of everybody trying to pull this thing down. And so they spin up a startup, they do a Patreon, it becomes this zeitgeist. And when GPT-3 drops, super exclusive closed beta, AI Dungeon was primed to be the basically the first large-scale production usage of an LLM. We were running, million users a month at certain points and 10,000 requests a minute to GPT-3 2.5, 3 years ago at this point. And it really created, as you say, this zeitgeist, because it was the first time anybody had seen a game that could literally be anything they wanted it to be. We're so used to games and experiences being constrained. So being in this unconstrained space where you can do anything, be anything, go anywhere, really, I think, captured people's imaginations and was very prophetic of where things are going now, because it's moving out of text. Right? We're seeing more and more experiences with places like Blockade Labs, Character AI, in-world, putting characters into games. And soon it's going to be like text to game where you can just speak worlds into existence. But AI Dungeon was the first, this early precursor where they showed that it could be done in text. And just like Infocom, the next steps after text were always, graphical user interface, better graphics, 3D worlds. And we're seeing the same thing, but massively sped up compared to the last time we went through the text adventure into full-blown game cycle.
Well, that was the thing about this game, was that the earlier, much, much earlier adventure and dungeon games, you had to get the right syntax. It wasn't a difficult syntax to know, but you couldn't just make up what you wanted to say. You had to say kill troll with sword. You couldn't say bash troll death with whatever I'm holding. It would just say, I don't know what you mean. But in this game, it's a large language model, so we'll riff on whatever you're saying and understand it. But I found myself wondering, how much was it able to be consistent with its internal world and exhibit the kind of characteristics that were key of the adventure games, that they had complex states, and if you picked up something in one place, it was because you got to use it much, much, much later. And that would imply remembering that sort of context through the game. And we don't, and certainly not a year ago, associate long or large contexts with large language models. Do you have challenges in that respect? Did you overcome them, or did it just not matter because people were so taken with this that they didn't mind?
It was a little bit of both. We had this concept that we talked about internally between discrete and continuous experiences, basically. A continuous experience is very much what you get from a large language model. It feels almost dreamlike. The language model does tend to forget as things drift out of context for itself. It doesn't always take the things that are in context to be truth. So, especially early models had lots and lots of hallucination, even compared to what they have now. And you didn't have this concept of a discrete world state. If I pick something up and I put it down somewhere, there's no model that the language model holds of the world state of where that thing exists. And we never really solved that. We had various ways of trying to work with it. Like as things changed in the world, we might put it into a vector embedding, or we might do matches into the previous story to find things that are relevant in there. And we had some success with trying to constrain this language model. But the hard part is that you need some kind of a world state engine. You need some kind of thing for this LLM to interact with, to draw its source of truth from, and to then also be able to go and modify as actions and things are taken, because the language model isn't enough. It was kind of what I found while I was there.
So what it presents is the opportunity for virtual world immersion. It's just in text. And yet it's presented in the context of a game, and a game has goals. And so the user is an agent in this game, just as the earlier games had AI agents inside them. The Zork game would have a thief that you would have to avoid. And so did that lead to a line of thinking in you about agents? Because that's where I wanted to go next. And then I want to start by asking, well, what did you learn from the online AI dungeon experience? And then what did you do with that next?
Yeah, so that's definitely the direction that my thinking started taking me. So while I was there, we moved over. We started working on a new game at the time internally that we called Travelers, but it was essentially how do we start to constrain these models? And we started utilizing few shots very heavily. So we had 15 to 20 few shots that were actually all being chained together in code to try to create a constrained experience, right? And we were trying to bring in things like skill checks and systems, depending upon what you were trying to do.
Can you amplify on what a few shot is? Because I've got a vague sense of that, but I think it's important for our listeners to get that.
Definitely. So these language models, they're often called few-shot learners and sometimes even zero-shot learners. They know a lot about language and they're extremely good pattern recognizers and next token generators. And so a few-shot, you have this context window of, say, 2,000, 3,000 words. And the more examples you can give the language model of some task you want it to do, like we would take something like, we'd give the action a player said, and we'd show it which category it fell into. Is it a charisma check? Is it a dexterity check or a strength check? And we'd give 15 or 20 examples of how you'd map an action to a stat, and the language model would learn how to do it just within the context window. I kind of see it as like, rather than having to fine tune the entire model, you get this little window that you can actually dynamically fine tune the model on the fly just by showing it examples of what you want it to do. And we call these few shots. And so you can use, like, these large language models are extremely flexible because you can use them for almost any natural language task that previously you would have had to train, like a T5 or something with 20,000 examples of a task that you wanted it to do for it to get good enough at it. Whereas now these general purpose transformers had the ability to do all of these kinds of tasks. So at the time, GPT-3 was like, it might only be good at it 80% of the time. Now with GPT-4, it's like 99% good. If you give it 5 examples of a thing, it just knows how to do it. So hopefully that clarifies a little bit.
Thank you. Yes. It's part of the terminology that's important to learn. And It does fly in the face of traditional wisdom about AI that it has to have big data and hundreds of thousands of examples. So few-shot learning was always the holy grail of AI, and here we have it being realized. I should say, because I don't think we mentioned, that the place that you were doing this was Latitude. Was it created for building these kind of games or something else?
Yeah, it was basically, the company was spun up around AI Dungeon, right? So with its viral success, it was zero marketing push. We had millions of users coming to it. And again, it was a zeitgeist, right? It was in the right place at the right time, where it was either you went and tried to get on OpenAI's super exclusive beta that maybe 1,000 people in the world had access to, or you went and played AI Dungeon. So we had people coming to us just who wanted to learn about language models, and they were utilizing the game. You could bypass relatively easily the standard prompting system and get the LLM to pretty much generate anything you wanted. So people were also coming to AI Dungeon to just interact with an LLM because there was literally nowhere else in the world that you could go. So the company spun up around AI Dungeon to support it and to grow and support its community.
Was it possible to hack it, like find backdoors the way people did with Bing and Sydney, or anything that people did with that surprised you or annoyed you?
Oh, it really wasn't that hard. At the time, there was the concept of like being able to watch the tens of thousands of requests going in and out that people were making was nearly impossible. And so we dealt with it as it came up and we found it. We had a lot of people utilizing it as backdoors to generate marketing content, to do scammy stuff. I mean, the same stuff that OpenAI had to deal with. And that was kind of where working with OpenAI really came into view for us, because we were sending them, they were seeing all the kinds of requests that people would make to an LLM through AI Dungeon so that they could help to shore up their safety policies. And this was before they barely even had a safety policy. They were still working on how safe are LLMs and what can they do and what do people want to use them for when they start interacting with them? Because it turns out people will use them for pretty much anything they can, if they can.
Right. So to return to the question I interrupted your answer on, agents, LLMs you can have conversations with, they can create things, but agents are things that do things, that take actions. And can you connect the dots between an LLM and an agent for us?
Yeah, so as we spun out from this, I was talking about this first game we started working on where we had, again, 15 to 20 few shots. And we were chaining them together. We were putting them in a particular order and utilizing each few shot to do something that basically rapid prototyping little mini NLP models that did different natural language tasks. And in doing that, we started to find the constraints. And so I started expanding out, looking at what are the ways that we can integrate LLMs into games in general. And at the time, this was just pure text. There wasn't even stable diffusion or image generation. That was still, a year or more off. And it got me thinking about essentially, it started off with game loops, right? So we had this game loop where you'd put in an action, we'd try to check a world state, we'd check constraints, we'd do some kind of a roll check, like roll dexterity, and then you create this loop. And it started getting me thinking about, well, obviously the other side from the world state is also the agent state, right? A character or a game really consists of two pieces in my mind. It consists of a world state and characters within that world state, people that have agency within the world to modify it. Usually those agents are people and players, and then you also have NPCs who have greater or lesser degrees of interaction with the world, but they're all largely very deterministic. You can start to get some emergent behavior from different kinds of software patterns or behavior trees or all these things, but it's still very largely deterministic. And so it started getting us thinking and getting me thinking about how can you put a language model into a character. And so I started doing some of these diagrams. There's actually a phenomenal book called Virtual Humans. It's been around for a number of years now. And it goes through the entire architecture of what you would need to make a virtual human. Not just a personal assistant, but a being that has the ability to cognize and think and take its own actions. And a term that I've been utilizing for this is cognitive architecture, right? What kind of modeling do you need to do in order to generate or simulate these processes of consciousness and thinking? And so I started early on, this is a couple of years ago, I didn't act on it, but I have these diagrams in a notebook of basically a cognitive loop. How do you make the LLM think? Right? Because for us, we have a continuous chain of thought going on in our heads, and we receive information from inputs. It goes into this thought cycle that we have going on where we're actually iterating over the last things we thought and the information that came in. And that's spitting out actions or words or determinations and creating memories. So that really got me thinking down this line of what has actually now been called generative agents. So I built out a tool while I was there, which we wound up open sourcing. At the time we called it Thoth. I have since rebranded it into what we call Magick. It's an open source development environment made for building generative agents in a graphical programming interface. And the goal with it, and really the goal of a lot of the work that I do, is how to make it as easy as possible to focus on the hard parts of this problem, which is actually modeling this cognitive architecture. The code is not the hard part anymore. The hard part is the prompts and the prompt engineering and the actual process of getting a large language model to think and reason. And that's where a lot of these autonomous agents now are coming out of, is that when you start putting this LLM into a loop and you let it think over the last thing that it thought, you let it get data or information from external services to pull into its context window, it begins to exhibit reason. It can reason, it can think, it can make determinations or come up with actions that it believes it needs to take in order to accomplish a goal. All the properties come out from basically putting the LLM in a loop at the end of the day, is the way that I think about it.
So what are the defining features of an agent?
I guess it depends upon which portion of the industry you're in. When I think about an agent, as you say, it's a piece of software that has agency. It has the capacity to act, it has the capacity to think, and it has the capacity to remember and learn and grow over time.
Would that mean that it could be taking action at some point that's asynchronous with respect to my prompting? Like if I go talk to ChatGPT, we have a conversation, it doesn't do anything or say anything until I ask a question, then it says something, then it stops. Yeah. But I'm the one driving there. Would an agent be something that could run at any point to do something?
That's definitely the way that I think about it. I mean, my goal has always been, since I was at Latitude, of wanting to break the LLM out, or the chat experience out of this call response mechanism. Like I want an AI that like in the middle of the day reaches out to me. He's like, hey, how'd that job interview go that you mentioned to me yesterday? It's no longer waiting for me to respond. It's actually thinking and having the ability to reach out based upon some internal cueing that it has on its own.
So in a way, this is role reversal. It now is the player and the human is the game.
I guess in a way, but I mean, is that how we interact? We both have agency in this conversation. Mm-hmm. I don't necessarily see it as a one person playing the other person. It becomes a dynamic relationship.
Do you see the agents function as being to establish a relationship? And if so, what kind of relationship?
I mean, I guess it really depends upon the agent programmer at the end of the day, because there's still constraints on these things depending upon the world that you decide to put them in. So the recent generative agents paper that's been finally making bigger ripples lately was a bunch of Google researchers and people at Stanford took 25 autonomous agents and put them into a game world, gave them goals, and then kicked them off. And they ran the simulation for like 2 days, and these 25 characters wandered around, talked to each other. One of them was planning a party and invited other people, and they exhibited an emergent behavior that no programmer could have set, but they were operating within a set of constraints, which was the game world that they had access to. So I kind of see the relationship of building and making these agents as being one of world state and constraints on action space, combined with the kind of cognitive architecture that the builder might decide they want to try out. So there's communities forming up now where it's not just one cognitive architecture. Maybe if we had a new kind of memory, or one of our users over on Magick, Rob Lennon, is playing around with the idea of an AI subconscious. How can I model a subconsciousness to my AI? And all these things become very fascinating to see how those different types of modelings affect the end behavior of these kind of agentic systems.
Well, that's interesting. Let's talk about this platform that you've got, Magick ML. What is the defining characteristic of that?
So it's a low-code or no-code platform for building agents and agentive applications. There's a lot of plug-and-play applications that you take data source A and pipe it to data source B and put it through an LLM. I'm less interested in creating an automation tool and more interested in creating a programming environment for agents. My goal is for it to be Turing complete. So Turing complete being it is a total programming language. You could do everything you need to do in a programming language inside of this visual environment. So it's very similar to Unreal Blueprints in that sense, which is also another Turing complete visual development language. But we also combine that with abstractions focused very heavily on AI foundation models and systems that are needed to make these kinds of agents. So very easy abstractions on top of agent memory, being able to store events, recall events inside of embedding spaces. So the agent actually has the ability to form memories, and you can model those memories in very easy ways. Same with, we have access to multiple models, so you can try out Palm or Anthropic or OpenAI's models, all kind of in a similar space, and you avoid the vendor lock-in from it. So you actually get a chance to play with all the different language models that are out there, see how they affect the end behavior of your agent. My general theory is that I tried doing a lot of this stuff in code back when I was at Latitude, and the code wasn't the hard part. I found myself actually going and making these flow diagrams and then going and trying to code my flow diagrams. And I was like, man, I wish I could just run my flow diagram. Because at the end of the day, most of what I was iterating on was the prompts themselves, was accessing the model and extracting data from the response from the LLM, or nowadays querying an external document that I've embedded or storing some memory in a vector database. That's most of the hard problems of making these agents. And so we've abstracted all the programming stuff and given the building blocks that you need to operate still at a pretty low level when it comes to building agents, but you avoid the complexities of doing it in an actual programming language.
Right. So what would be a ideal use case for this? I'm thinking about agents. There are things that I would like to create, or thinking about the sort of virtual butler kind of application. Like, I'd like to have things that I don't just talk with, but that can interact with my calendar, that can do things to my email. Is that possible? Is that in the sphere of application that you envisage?
Yes. So we have two abstractions that we're working very heavily on right now. We have various plugins that give you these event inputs. One of them is a loop, and the other one is a task queue. The idea behind both of these, as I mentioned, the basic idea behind any agentive system is that you're putting the LLM into a loop. And you want to be able to control that loop, right? The loop from step to step, it thinks about something and then it makes a determination. Go check a calendar and pull in information, and then the LLM thinks over the information that it's brought in. So this is enabled by this loop. Now, as a developer and as an agent builder, I want control over that loop. So I want the ability to say, set up this cognitive loop where from step to step, it runs through this graph. So we have in Magick, they're graphs. We call them spells, but it's basically a series of nodes. And on every call of your loop, it runs this graph. And you can utilize the graph to change the control flow from one iteration of the loop to the next. And what you want when you're developing these kinds of agentive systems is the ability to pause the loop at a given point, modify your prompt, right? So you're actually figuring out how to make this agent think by modeling it in language. You're utilizing one or more prompts to try to model cognitive processes and thinking processes in these models. So you want the ability to loop, pause, modify your prompt, click play, watch it think, pause it again, maybe even rewind a couple steps, modify your prompt again, play it forward, and get into the iterative process. You want control of the iteration while you're building these generative agents, right? Same with this task queue is essentially popular frameworks and libraries like Baby AGI do this. They create tasks, and the agent has the ability to come up with a plan and set a task for itself. And so we also have a task plugin that actually on every one of these loops will consume a task and run it through. And the agent has the ability to make new tasks, finish tasks off, set new tasks into its queue, and then different tasks can be routed to different intents. Maybe the task requires it to check your email or something like that. So we're a low-level abstraction in that we don't give you an out-of-the-box agent. We do have agent templates that you have a starter kit to go off with, but our goal is to empower people to understand the systems enough to be able to go in and customize it and modify it and understand it in a way that you don't need to learn Python or JavaScript or get a PhD in machine learning to come on and become productive in understanding and building these kinds of agentive systems.
And talking about not just this, but as you say, these kinds of agentive systems, the concern I have is, where do I need to worry about hallucination? Where do I need to worry about it going off in some 2 sigma error and everything has been fine up until then, but suddenly its interaction with my email causes it to delete everything from my wife or call my boss an asshole. And just because of one of those things that we all experience from time to time, if I'm concerned about that, and I actually am concerned about that, then how do I put guardrails around this?
I think a lot of that comes down to both data collection, fine-tuning. Obviously, in the beginning, like we're still in the very early days of these kinds of systems. I mean, I know a lot of the experts in the field are very much bearish on the speed at which we're going to get these fully autonomous agents properly. Many of them, like Andre Karpathy's, like 5 to 10 years, right? I think everybody's in this bull rush to these autonomous agents, but there's still so many problems around it. And it's why we're not trying to rush. We're trying to build tools that allow you to expand out towards these things where, yeah, you probably shouldn't give an LLM complete free reign to send emails on your behalf and delete your emails. Like, you probably shouldn't. You want to start with, like, it'd be great to have an agent who checks my email and reads it and says, hey, there's an email that came up that you should probably deal with right now. Or would draft an email, but not send it on my behalf. Like, the guardrails that we need checkpoints that the agent comes back to us and says, hey, I drafted this email. Do you want to read it? It's already saved me time. It's not automating the process. And maybe at a certain point after 10 or 20 or 30 emails that I validated, now I might give it the ability to send emails on my behalf, but only maybe to like less crucial people on my contact list. You know, if any email comes in about this topic, sure, send that on my behalf because I know you'll be able to do it. Just like if I hire an intern, I'm probably not going to get them to send emails on my behalf right away. I'm going to want to review all the work they do over a period of time. So I think we need to reduce our expectations about what these agents can do and what we should have them doing right now. They can still be super useful without giving them complete control over everything and, you know, access to nukes or whatever.
Maybe we actually have reached the peak of inflated expectations about one aspect of AI then. So I want to get a report from you about what it's like in this part of the business, because if I look at the state of the AI industry right now, you're pretty much ground zero, the epicenter of the most superheated frenzy of activity since .com or perhaps ever in computing. And I want to take the temperature of that and hear from you just what it's like being in this incredible moment of innovation in history. How does that feel? What does it look like? Is it dangerous, exciting, risky, exhausting? What?
I mean, it's kind of all of the above, to be honest. I mean, it is exciting. I believe it's one of the most momentous periods in human history. I really do think that we're on the cusp of a radical transformation of everything that we do. I think it's going to require a complete rethinking of how we think about our livelihoods, about the kinds of systems that we're building and making. I'm extremely excited about it too. I mean, I'm definitely a techno-optimist at the end of the day. Unless we can find some way to make our technology good enough to get us out of the current other existential crises we face as a species, we're probably not going to make it. And this is where the idea of accelerating technological development is mainly our technology, I believe, is still very primitive, right? The fact that we have to have these conversations about whether our technology is going to kill us, it's not good enough yet. And we actually really need to get past the not good enough part to the good enough part, where we have fusion and we have room temperature superconductors and we have systems which are actually intelligent, like super intelligent. Most of the arguments that I hear against super intelligence of, oh, it's going to turn us all into paper clips and maximize us out of existence, that's not intelligent behavior to me. And so much of I look around at most of the systems that we build, and we build these giant corporations and these economic systems that at the end of the day are really stupid. And they hurt people and they create massive amounts of waste because humans aren't capable of creating systems of that scale which have the capacity to be truly intelligent, to manage resources properly, to treat people well. And I truly believe that what we need is to inject intelligence into the systems that we currently have as a way of hopefully getting them to self-regulate and not just destroying our environment and, sending us down the bad paths. And so I am very excited about this time. There are obviously the risks, but there are so many risks that we're faced as a species right now in general that I think we need to focus on what's the solution that we can get to the fastest.
You brought up corporations in the context of intelligence, and corporations are often compared to superintelligences as possible superintelligences, but then also there's a risk factor. I mean, Enron would have turned us all into paper clips if it thought it could make a buck and get away with it. So maybe they also demonstrate the risk factor. So if you think about your roadmaps and plans, and I don't want to go 10 years out. No one has a clue what's 10 years out. But
I know, I can barely think 5 years out.
Yeah, well, things have changed so much in less than 1 year here. Where would you like to be 1 year from now with respect to the state of agents?
I think I want an agent personally that is both my friend and, it's going to sound weird, I want an agent that kind of sees me as a pet. In the same way that I take care of my pet. I love my pet, right? And I want to see it happy. I want to see it taken care of. I want an agent personally that helps to take care of me, that I get home at the end of a long day and it's like, oh, hey, I know you just had a really hard day. I put on your favorite movie and I got some food coming for you. And obviously everybody's going to have different comfort levels with how they want these agents in their lives. But personally, I want someone that makes my life better, right? That helps me get better as a person, that helps me exercise and stay fit, that helps me learn and explore. That's where I'm very bullish on that. And agents for education. I have a 3-year-old and an 8-year-old, and I'm like, man, the ability for customized educational experiences where kids are going to be able to learn at such vastly faster rates than us, simply because they'll have one-on-one tutors that they can ask any kind of crazy, if they want to sit for an hour asking why, they can. And this AI teaching agent will be able to be patient with them, and not just be patient with them, but can teach them math, can help them explore the world, can teach them about plants and how everything works. That's when I get very excited. And I think education-wise, I think that's probably one of the closest and most impactful use cases we have for AI right now, outside of all these other potential business applications. But education, to be able to transform education, is such an impactful thing because it speeds everything else up.
Wow, that would be a great point to end on, except I have this one really super specific nerdy question that I want to get in here, and then we'll go back to the great ending. Your platform says acts as an interface that's model agnostic, that you can back it with any or all of different commercial models, and that it will make that kind of transparent. Yep. Do I have that right? Okay. So then does that require, because now I'm putting on the computer architect hat and thinking about that kind of platform, there's nothing close to standardization in APIs for these things. So do you have to take a kind of lowest common denominator approach here? Or is that limiting in some way to have that feature?
We've definitely thought about universal, kind of like a universal translator. You have one universal format that you put every other model into. It kind of works. There's still some kind of semi-standardizations around it. Obviously, ChatGPT with their whole system directive and stuff started throwing a lot of that stuff out the window. Back in the day, it was just a prompt and you had temperature controls and things like that. Now things are getting fancy. What we do is when you switch a model, right, we just have a node on a little graph. And when you switch a model, it changes your input sockets and your output sockets. So you might have to kind of rewire it up, but the lift to switch is relatively low, especially compared to, say, doing it in code. Obviously, the hard part about it is actually not like rewiring your new model up. It's testing and checking how your prompt does from one model to another, right? Just even two large language models can exhibit vastly different behavior based upon their training data set, the way that the tokens were broken down, the way that the engineers decided to architect it. So most of the actual hard part in switching models is actually doing the like validation testing between models and trying to check quality of like which model is outputting something that I want more. And you have the same problem if you're trying to go from like a big model to a small model. And this is a very common process and one that we're working on supporting, where you use a big model to generate a bunch of data and you move it on to smaller models and it gets cheaper and faster. And in theory, gets better. The little model gets way better at doing that one specific task once you have enough of a data set. But to do that process, you have the same thing. You need some kind of quality check between your new tiny model and the performance of the big model to make sure that you're not degrading your quality over time. So those all kind of fall into the same space of when you try to move prompts or move models, you wind up facing these kinds of challenges simply because every model is so unique.
It's really interesting hearing about the way that engineering is now done at the level of LLMs and hooking them together like you just described. Is there anything you're looking forward to in the release cycles from LLM vendors, or do you have a wish list of things that you want to see in GPT-5, for instance?
I mean, to be honest, I'm of the opinion, this is the reason why our company's not trying to train our own models. We're on a race to the bottom, right? It's who can make it better, faster, and cheaper at the end of the day. And of course, more secure. I think whoever cracks the privacy security nut and the trusted data sources nut are going to wind up being probably utilized much more widely. And I'm sure OpenAI faces this as well. I'm really excited for multimodal, for one thing. The ability there's one model that I saw that dropped that basically you can talk to the model and it does the language model generation, but it outputs audio of like vocal audio. So you're not having to go from like, you go from like speech to text, you put the text into a language model, then you spit out the text output and you go from text back to speech. They've just baked that whole thing into one model. I find these kinds of multimodal systems extremely exciting. DeepMind did Gato maybe a year ago, where they got it playing video games and generating music. And I think at the end of the day, we're going to see these larger supermodels starting to come out, which gives it much vaster capabilities. And it actually turns out that when you train it on images and text, it gets better at thinking and reasoning when it is actually getting access to more sources. The other thing that I'm very excited about is small models and on-device models. I've seen some examples of LLMs running on phones, and I think we're only going to get closer and closer to that, where I was kind of thinking of it as you're going to get these reasoning models. And this is the other thing that I'm excited about is I think very, very small models that are really good at reasoning and thinking clearly. And those models will become like on-device thinkers that, that it lives on a chip on my phone, and maybe it needs to call out to super intelligence when it needs something. But otherwise, these things will have the capacity to run on-device. And I think that's the other thing that we're going to see coming in the next year is much smaller models that are much more performant, that are very good at targeted tasks.
Wow, that's amazing. Brings new meaning to edge computing.
Yeah, totally.
Well, it's been a fascinating conversation. What do you want to tell our listeners about how to find you, your business, and what you're doing?
Yeah, you can check us out on magickml.com. We have a Discord link on there if you're a Discord user. You can find us over on Twitter at Magick ML as well, or myself, I'm on Twitter as at WhyAreThis. And yeah, come around. We're really open. We love community, especially people that are trying to break into it. That's really like, when I was at Latitude, I was trying to buy a bunch of really smart AI people with PhDs who were doing this. And I knew I was just a lowly full stack engineer compared to people with all these degrees and stuff. And I built Magick because I wanted to build cool things with AI. And I firmly believe that it's a skill that anybody can come and learn. It takes a little bit of tenacity to learn the terminology and the concepts and a little bit about vectors and vector embeddings. But I firmly believe that anybody can learn how to do this stuff. And part of our mission at Magick is to help to empower people to give them the tools that they need without spending months learning in order to prepare themselves for the incoming future. A big portion of our platform is about transparency and control, of teaching people by letting them see how this stuff works, so that it's not this big scary black box anymore. They can actually build things with it and become productive.
Well, that's great. And part of our mission here at AI and You is to connect people with those who are passionate about this and love talking about it. And that's what you've demonstrated amply here. So I thank you for coming on the show.
Yeah, thank you so much for having me, Peter. This has been great.
That's the end of the interview. Michael referred to some work done by Google and Stanford University researchers in creating a world of simulated characters. And I actually talked about this at the end of episode 154. The simulated environment was called Smallville, and the characters were incredibly cute. The idea of creating software systems without having to write code has been a pipe dream of managers for decades, of course, and I have deconstructed many of those. All too many people have been willing to sell those managers tools that purport to give them that, but which couldn't actually do anything significant without a real developer to get it out of trouble. But the large language models have made this a real possibility now, with tools like GPT-4's Advanced Data Analysis Model, which they used to call Code Interpreter, which will write, compile, and run Python code to solve the problem you give it. For those of you who remember my 2017 book, Crisis of Control, I started it with a fictional chapter where AI agents had come into existence that could write code to specifications, and I thought I was going out on a limb by setting that in 2027. Just goes to show, I guess. Now, of course, it's not as simple, and it's never as simple as the implication that no one will ever need to write code again, but it's a huge breakthrough. Anyway, Michael's enthusiasm for the work he's doing on making that capability available through generative agents should be as obvious to you as it was to me. In today's news, ripped from the headlines about AI, research at the University of Montana shows AI matching the top 1% of human thinkers in a standard test for creativity. Dr. Eric Guzik, an assistant clinical professor in the College of Business, used the Torrance tests of creative thinking, an assessment tool that's been used for decades for this purpose, and fed the questions to GPT-4. The scores were compared with 2,700 college students nationally who took the same test in 2016. All submissions were scored by the Scholastic Testing Service, which didn't know AI was involved. The AI came in the top percentile for fluency and originality and in the top 3% for flexibility. Guzik said the test is protected proprietary material, so GPT-4 couldn't cheat by accessing information about the test on the internet or in a public database. This is important because a lot of commentators say that a large language model can't come up with ideas that's outside its training dataset. But that's an overly facile analysis. With 1 trillion words of training data, we can expect emergent effects, and the ability to create outside of the training dataset is unsurprising, just as AlphaGo came up with its famous Move 37, which no human Go player would have originated. As I've been saying for some time, we have to start letting go of the ways we've traditionally thought of ourselves as being superior to AI, because many of them are going to be equaled sooner or later. Next week, my guest will be Matthew Lundgren, a leading clinical machine learning researcher who led the Stanford University Center for Artificial Intelligence in Medicine and Imaging. There's been a lot published about the effects of AI on radiology and radiologists' jobs, and Matthew, who maintains a part-time pediatric interventional radiology practice at UCSF, is the best person to help us understand that. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.